In this video, we are going to build a polygenic risk score for COVID-19. The goal here is to finding a new drug or existing drug for treating COVID-19, and that's called drug repurposing. The first step is getting the data. Data is a public data on the geodatabase, and you can use R or Python to download the data, or you can directly download data from this website. When you download the data from that website, we need three files. The first file is the expression file, which we have sample key on the column and probes on the rows, and the rest are the expression files. The second file is probes, is just a simple lookup table. And the third file is the target file. The first column is the unique key for each sample. And the second file is the cell line. The third file is the infected with, which we can see the different value, which is mock infected and SARS-CoV coronavirus wild type and SARS coronavirus Delta E. There are three different types of infected with. And the fourth column is the hours post-infection, which we have 5 different hours. Okay, then that's the, now when the first step is we just get the name of our database based on the same GSE. We connect to a smart array. You click on that plus sign, click here with the name of our database. Now we connect to the database, get the expression file, and automatically we get the name for the probes and targets. Now we click and upload the file to the database. Now we upload the targets. Now we upload the probes. At last step, we upload the expression file. The expression files has many probes and more than 50,000. We cannot have a table with 50,000, then we need to slice them. It takes a few minutes to process that data. We pause here for a few minutes, then we come back. It's almost done. Okay, now we have expression file in our database. Click here, and this is our newly created database. We have our fact table here. Now we do some univariate analysis. For example, on the infected with, we have 3 values: SARS-CoV coronavirus wild type, SARS coronavirus without E protein, and mock infected, which means no infection. And then we just need 2 of them, which is the wild type and Delta E. We put a filter on it, and now we have 2, which is 50%, 50%. Another attribute we like to see is the hours post-infection, which we have 7 hours post-infection, 15, 24, and 65. And now we want to see the bivariate chart 4 hours post-infection and one of those probes. This is the probe, and for each bar we see the average of that probes, and we see the lowest on the 7 hour, then it goes up 15, the peak is on 24, then it's going to come back. Okay, we have this chart, but we want to have the same thing for both SARS coronavirus wild type and Delta E. Then we can use the option 8 here. Say, let's have the same thing for both group, wild type and Delta E. And now we can just check that chart for every probe, but for sure we can do it for 50,000, more than 50,000 probes. Now we use the automated version. With this option, we automatically analyzing each probes using analysis of variance, and it takes time. We pause here for a few minutes, and then we're going to come back. It's almost done. Okay, now if we look at the first selected probes, we see a completely different behavior for SARS coronavirus Delta E compared to the wild type. This is the Delta E has a clean line. It's going up every hours post-infection, but the wild type has a completely different behavior. And we don't need to work with all that 50,000 probes. We just save top 200. This is the beauty of using relational database, because we can manage our data with all those features from the relational database management system. Now we download the top 200. It's much faster to analyze it. Okay, that's beautiful. And now we go for the further investigation. This is our top 200 probes, and here we have uptrend, downtrend. It just make sure it's not up regulation here. Mostly is we want to see the trend in our chart. Okay, we select top 10 probes here, and we try to find any matching chemical or substance or drugs. And here we see there are a few chemicals which they match the same behavior we have in our list of probes. It means silicon dioxide upregulate 9 out of that 10, and without downregulating anything here. And this is just one probe, this probe, which has been down. It has a downtrend in our list, but we don't have any record for silicon dioxide. You can see on the top 10 list, this is the only gene which has a downtrend. Cadmium atom, silver, cobalt, paracetamol, and one of the this drug is the cyclosporine A, which upregulate that uptrend, eight out of the 9 uptrend chemical. This one is a bit down and up. That's the only mismatch, but at the same time, it's downregulate that downtrend gene as well. This is a nice match. Then using a combination of cyclosporine A, paracetamol, silver, and silicon dioxide, maybe a potential mixture which might stop coronavirus, COVID-19 disease. That's the option which we can think about. This is just theory. We need to prove it. This is what we call a drug repurposing, and genomics data can help us